Hi everyone. Okay, sorry about that. My camera decided to just turn off during the middle of the lecture, so I have part one uploaded, and this is just part two. This will only be a few minutes because we were almost done with the PowerPoint. But so sorry about that. Okay. So I was on the slide 28, and we were talking about when cultural relativism must be considered. And I was talking about sneezing. Okay, so we'll move on to the third point. So what is wrong? Next, what is right? What is considered normal? What is considered odd? Like I said this before, like what is, the morality, can you use it then? So I had, like, when and why can it be applied? Okay, so I have some examples, I think. So slide 29. So like I said before in the previous video, like what is considered attractive. This is going to be very different from group to group. What is considered attractive and what is not. Next slide 30, what is considered appropriate. So I already gave you the sneezing example, but also per this cute meme, even like other bodily functions, burping, farting. In some cultures, no big deal. Other ones, completely offensive. Like if I sneeze, which I can't really help, everyone says, bless you or God bless you. But if I maybe fart, which sometimes maybe you can't help, everyone's like, oh my God, that's disgusting. So just think about that, like from culture to culture, like we have these kind of social rules that you don't really put too much thought into, but it's not going to be the same from group to group. And 31, what is considered right and wrong. So I have a couple of examples because so about food and about eating animals as food. So we'll talk about this from a cultural perspective later on. We have a whole section on like food. But looking at this in terms of like, is this a moral thing, or is it to you? Is it like an amoral thing? It's morality isn't even part of it. But for some groups, some cultures, subcultures, it might be, it might not be. But even in general, you're going to see different animals being eaten in different cultures, and some are going to be like, you shouldn't eat those versus in other cultures. So like, for example, like plenty of us have dogs, and like per you guys have already seen, I spoil my dogs. They're like my little kids. But in other cultures, they eat dog. So this is very different. And just like how most people would, if you guys are, any of you are meat eaters, you probably eat cow. But in some cultures, cows, you don't eat cow. So from culture to culture, it's going to be different. And then even things like who you fall in love with, if you are heterosexual versus homosexual, that can have very different implications for what culture you're in. So when I was in Ethiopia, it's like actually illegal. Like you can get arrested for being homosexual. And so that was kind of interesting to see. And I remember talking to a couple of the museum employees. Like I don't want to push the issue because it's like a very taboo thing there, but I kind of generally asked about it, and they were like, oh yeah, no, completely wrong, totally wrong. They just had some very strong opinions on it. Versus here, especially like in 2020, you're like, oh, who cares, most of the time. Okay, slide 32. Oh, and this, what I just said, my dog. So what is considered normal or odd? Other cultures might be like, it's so weird that you have dogs as pets, that you like dress them up sometimes, that they sleep in the bed with you. That might be weird to some people, but in our culture it's like very common. And then okay, so this is what I was saying earlier. So is there a point, so per the question on this slide, is there a point where relativism can't be applied? And this is what I said, this is a question for you to think about. You might say, okay, I get it, like 95% of the time this makes sense, but there's that one thing I still have a problem with. That's a completely legitimate perspective, and we'll talk about that more. Okay, slide 34, emic versus edict. So this is just basically, do you have the insider view of a culture or the outsider view? Are you coming in as an outsider, and so that perspective on what that particular group is doing is going to be very different from someone who is in that culture. Their perspective of how everything works is going to be very different. And so I have a picture here of like the toilet, like what you see, what your dog sees. So it's perception often. Okay. Oh, that's right. We have a little bit on what is science in this. Okay. What is science? So this is a science class. Even though you might be thinking, well, it's cultural anthropology, still science. So we're going to do a little bit of overview of things you probably got, in high school, junior high, but just a little bit of an overview. So what is science? So this is the way that we gain knowledge. Like as a society, we've agreed the scientific process is the best way to gain knowledge about our reality. So slide 36, the scientific method. So you probably got this in some version in elementary school, junior high, high school. Sometimes, there's like a fifth step or sub-steps, but this is the general, what I have on the PowerPoint. Observation, hypothesis, experiment, and conclusion. So I'm going to tell you right now, I'm pretty sure this is on the first exam. Like if I asked you, hey, could you list those 4 steps? And could you give me a 1 to 2 sentence description of each of those? Pretty simple, right? But just know, like, I'm just on your notes, like little star or something. This will be on there. I'm 90% sure. But when you think about it, like, we don't always think about like science. Okay, there's actually a very specific process to it. But the science is more than just the scientific methods. So this is some of the other things I have listed here. On slide 37, how to maintain objectivity. So how do we remain objective? How are we sure that we are getting factual information versus like a subjective opinion? That's what you want to avoid in science. But like anyone can have an opinion about anything. But when you want like scientific objective information, like a climber back here just doing something. Okay. Like what are the ways that we can try to get as close as we can to objective truth, objective reality versus like your own opinion or your own bias you want to avoid. So there's some ways in the scientific method process. So one is that anything you do has to be repeatable. Anyone else has to be able to come along, any other scientist, and say, I'm going to repeat that same experiment. Maybe they change nothing, maybe they change one thing. It has to be repeatable. And this is going to make sure that, we have scientific validity. So like if you were prescribed a new drug and the doctor said, oh, there's this new drug, I'm going to prescribe it to you. There have been 2 studies done on it and it seems like it's working. Versus another drug, and she says, oh, well, there's been 80 studies done on that one and that one's good. You'd probably be more likely to go with the one that has been repeated over and over again to confirm conclusions, That's always important. Number 2 on this, so it must be falsifiable. So the way you've set up any experiment or data collection process, has to have the ability to show that your hypothesis is wrong. And you might be thinking, how can that not be? You'd be surprised how sometimes people create like a experiment that doesn't really have that ability. You have to be able to say, like, when you have your like hypothesis or null hypothesis, like, this is what I think is going to happen, maybe not, maybe yes. And your evidence might back up, yes, you were correct, yes. Or it might say, no, you're wrong. Okay. And both of those results are important in science. But the way you set up any experiment has to have that ability to either be like, you were right or you were wrong. And then, of course, 3, very important. This is actually what kind of separates science from other forms of gaining knowledge, is that it changes with new evidence. Doesn't mean science is never wrong, because, of course, it's going to be wrong sometimes. But this is the beauty of science, is that it's a self-correcting system. Because it's repeatable, falsifiable, and changes with new evidence, that it's always moving towards factual truth, reality. And sometimes even if we get it right, but we don't have it fully right. So like with new technologies often, so like DNA, we thought we understood, let's say for example, primate relationships, like the relatedness and ancestry of all primates. We've got it pretty much right. Then we get DNA and we realize, oh, well, we thought we were closely related to chimpanzees than bonobos. But I'll tell you right now, like 6 months ago, this study came out showing that we're ever so slightly more closely related to bonobos than chimps. Now it's only one study, so we need more studies to confirm this. But if this shows to be true, that's new evidence changing slightly what we thought. And sometimes new evidence can completely change like huge things about what we think. So changing with new evidence, it's hard sometimes. You see a lot of older professors, older scientists like, I don't know, I think my idea is right. Well, okay, dude, but like the evidence is now pointing towards there's probably something else going on. So this happens. Also built into the scientific process, so slide 38, is peer review. This is very important. You probably have heard this term, but basically as a scientist, what you do, you have your idea, you do your experiments, you have a really cool, process, and you're using the scientific method. And well, then you have to get that information out to people. So now you would want to submit it to a scientific journal. You're not just gonna like post it in your blog, because you want peer review. You want other people in your field. This is what happens. You submit an article to a journal. It gets sent out to members of that journal, like anonymously, and then they critique it. Oftentimes, like per this meme, one or two reviewers like, looks good, solid work, maybe change like, the way you formulated this sentence and maybe expand on your description of this, statistical process a little more, but otherwise looks good to go. And then you might have someone who just tears the whole thing apart, like, this is bullshit, It's kind of a joke in academia. But you want other people in your field to look at it with a critical lens and say, because if you submitted something and you have 5 people in your field saying this is solid work, you'd be like, okay, I feel way more confident in that. And anyone else who uses that information in the general public, they will also feel more confident in that information. But if you submit something and other people in your field are like, this is wrong, you'd be like, oh crap, I probably did something wrong. Like, you want that extra backup. Okay. Slide 39. So some of these last couple of slides are a little wordy. Don't worry about that. I'll just explain to you what I want you to take from them. The term scientific theory, for whatever reason, this is very weird, it gets used incorrectly all the time. It's because we use the word theory in a different way in everyday conversation. So if I said, just having a chit chat with a girlfriend, I have a theory about blah, blah, blah. Analogous in scientific terminology would be the word hypothesis. So if I use the word theory in everyday conversation, I'd probably be saying I have a general idea, I have a good guess, maybe even based on some evidence, but it's not really backed up by anything, just my general opinion, really. In science, that is not what we mean by scientific theory. Scientific theory does not mean a good guess or not validated. That's not what it means. That would be a hypothesis. A scientific theory, and this is what these last 2 slides, they're kind of wordy. This is what it's explaining. That you want your field to be a scientific theory. That's the pinnacle, the height of any field. You want, we now have a scientific theory, because what that means is that it has been tested and tested over and over and over again. It has been validated by multiple people, different, universities across the world. Through time, it has been shown to be correct. And so that's what you want. But also the other thing about, I hear this sometimes, well, why don't we call it scientific fact or a scientific law? Well, we have in science, when we say the blank law or whatever rule, we talk about those in this class later, and the ones we have in anthropology. Those define specific instances, specific circumstances, smaller circumstances. It's when you can compile all of those laws together and this is explaining an overarching idea, and that's when you have a theory, if that makes sense. Okay, so using the word theory in everyday conversation is not the same as using the word theory in science. And then the very last slide, slide 40, you'll see some scientific theories. So gravitational theory, of course, evolutionary theory. We'll talk about that in this class. Cell theory, germ theory. No, you would never say, well, gravity is just a theory. But you hear people say that about evolution. It's very strange to me. It's a very uniquely American thing, too, for the most part. But whatever. You would say, well, gravity. You don't go around saying gravitational theory. We say gravity, just like we say evolution. But if you want to be technically correct, you'd say evolutionary theory. But saying evolution is just a theory, just that expression alone tells me you don't have a background in science. Scientific terminology, scientific process, evolution for sure, biology. So it's only because we have the same word and we use it differently in everyday conversation. So it's a little frustrating. Okay, so that's it. Once again, sorry about the 2-part. My iPad hasn't given me problems for forever, and now in this last week, during the first week of the semester, it starts to give me problems, but I'll get it sorted out. Okay, I will talk to you guys later.